So we're going to talk about pedigrees today. If you don't know what a pedigree is, don't worry, I'm going to show you. Pedigree, the first thing we need to write down is that a pedigree is a diagram that shows related individuals and the genetic diseases that they have. This is an example of a pedigree. You'll notice it looks a lot like a family tree. And it is a family tree of sorts. The difference here is that we have specific symbols, and no matter which individual's writing a pedigree, they always use the same symbols. And we're going to talk about those symbols, whether or not they're shaded or circles or squares, and what all of the numbers mean. So in our pedigree, squares represent males. So you want to write down that squares represent males. You can just draw one square, no need to draw both of them. It's just showing you that sometimes they're shaded, sometimes they're not. Circles represent females. So anytime you see a circle, it's a female. Anytime you see a square, it's a male. If they're filled in, shaded, and by shaded I mean shaded dark here. I know these look light gray, but anytime that they are dark, black, that means that they have whatever condition we're looking at. So whether that be cystic fibrosis, whether that be hemophilia, whether that be, dwarfism, the condition's always going to be shaded. And in our case, the conditions we're going to be looking at are going to be recessive. And we'll talk a little bit about that in a second. So shaded means they have whatever disease we're looking at. And remember, this has to be a genetic disease. This isn't like, oh, the person has a cold, right? Because colds are not passed down from generation to generation. When we number a pedigree, you'll notice on the left-hand side we have generations. These are written in Roman numerals. So these are the generations. Generation 1 is all the way across here. Generation 2, Generation 3. We number the individuals from left to right. So each row gets numbered. And these individuals go from oldest to youngest. So number 1 is always going to be the oldest in each row. When we refer to these individuals, we're going to refer to them by their generation and their number. So if I want to talk about this one, it would be 1-1, and we'd use this Roman numeral, put a dash and a 1. If I want to talk about this individual, it would be 2-3, and the 2 would be written in Roman numerals. So how do we solve a pedigree? Okay, here are our steps. The first step, we're going to identify all the individuals that have the disease, or all individuals who are completely recessive. So for all of our shaded individuals, we're going to put 2 little a's. For all of the non-shaded individuals, we're going to put a big A and a blank. We don't know yet if they're big A, or if they're going to be big A, little a. And then we're going to fill in the remaining letters. So let's take a look at step 1, right? Step 1, all the shaded individuals have 2 recessive letters. You'll notice I went ahead and added 2 lowercase letters to each individual who is shaded. Okay. Next thing we're going to do, add a big A, 1 big A to all of the remaining individuals. Again, we don't know if they're big A, or big A, little a. We're going to figure that out in a second. Once we do this, we're going to use clues. We're going to kind of do Punnett squares in our head, and we're going to use some clues to help us figure out some more of these letters. So each individual is going to have 2 letters. I tell people to always start with the individuals that have the disease, the shaded individuals. Okay, they're going to give you the most clues. So let's start up here with this shaded individual. You'll notice there's a line, it's kind of hard to see because I obscured it. These 2 parents have 3 kids, 1, 2, and 3. All right, and their kids, 2 of them are little a. Well, we know that each kid has to get 1 letter from mom, 1 from dad. So they had to get 1 little a from mom, 1 little a from dad. So we know that dad has to be big A, little a, because he's got to give a gene to the kid, right? He has to be able to give a little a here for that person to have cystic fibrosis. If we look at these two parents, they had this kid. Okay, these two parents produced a kid with a big A, and we need to figure out what the second letter is. We know the big A had to come from dad here. So the little a, mom only has little a's to give. So mom is going to give a little a, which makes this kid big A, little a. All right, let's go over, we can go to the middle here. We know that these two parents have two kids that both have cystic fibrosis. So this kid's got two little a's, which means one little a has to come from here. One little a has to come from this parent. So this parent has to be big A, little a, so they can give a little a to their kids. If we look over here, we've got another situation where we've got two little a's. One little a has to come from one parent, one to the other. If we look at the kid here, we know the big A has to come from dad. The other letter has to come from mom, and mom only has little a's to give. So mom is going to be little a. We just have to finish up the left-hand side here. You'll notice we don't have any kids with cystic fibrosis. So do we know if these are big A, or big A, little a? We don't really know. This could be a big A. Could also be a big A, little a. We are not entirely sure. So what we're going to do is we're going to write a question mark next to each letter. Okay, so if it could be big A, or big A, little a, we just write a question mark, and that indicates that it could be either. And that's how you solve a pedigree. Some of them might have more question marks than others. It just depends.